In this video, we're going to look at some concepts of the unit circle. So consider the unit circle, or consider the place at which the unit circle exists, in that we've got a Cartesian plane as such. So this horizontal axis represents the x values and this vertical one represents the y values. In the area above the x-axis, we call this the positive region for y, and the area below the x-axis is the negative region for y, and the area to the right of the y-axis is the positive region for x, and the left-hand side of the y-axis is the negative region for the x. So this is where all of our negative x values are. Now the unit circle itself, we define it as, say if we had a length of string and we fix it at location 0, 0, then we stretch it outwards to a maximum length of 1. So 1, 0. And then we fan the string around. So notice that the string itself, it's always a length of 1, so its location on this Cartesian plane is always going to be a unit distance of 1 away from the origin. So if you did that, you'd map out a perfect circle. Now the way in which we can describe the location of this point, so this point on the circle, is we can say, alright, well, if our length is something like this, and what we find is that we map out, or we can map out a triangle to represent the vertical and to represent the horizontal components, and this triangle has a right angle there. So this side length here, this side length can be represented, or if our angle's in here, theta, this side length is the opposite, and this side length is the adjacent. Okay, so to work out the vertical distance away from the origin, we could say the sine theta equals the opposite over the hypotenuse. And because the hypotenuse is equal to 1, then the sine theta is simply equal to the opposite. And similarly for the adjacent, we can say the cosine of theta equals the adjacent over the hypotenuse, and it's simply equal to the adjacent, because remember, the hypotenuse is equal to 1, so cosine of theta. So because of that, we can describe the position on the unit circle. So the position on the unit circle, we can describe the x values, so this adjacent component, or the horizontal, as the cosine of theta, and the vertical as the sine of theta. Now notice, as this point moves around the unit circle, it's going to pass through 4 different quadrants. So recall that along the vertical axis in the positive region, we said that was 0 radians or 0 degrees. At y, we're going to get pi on 2 radians or 90 degrees. At the negative, or along the negative horizontal or negative part of the x-axis, we're going to be at pi radians, and at the negative y, we're going to be at 3 pi over 2 radians, and then finally back up to 2 pi radians. So as we revolve or sweep around this unit circle, this relationship here describes the location. So notice that when we go past pi on 2 and between pi on 2 and pi radians, notice that we're still going to be in the positive region of the y-axis. So we're going to expect positive values coming out of this sine component, but we're in the negative region for the x-axis. So we're going to expect negative values of cosine. So we get positive sine and negative cosine. Now for pi and 3 pi on 2, notice that we're in the negative region of the x-axis and the negative region of the y-axis. So we expect both negative values for sine and negative values for cosine. And finally for 3 pi on 2 and 2 pi, we're in the positive region for the x-axis and still the negative for the y-axis. So we're still expecting negative for our sine, but positive for our cosine values. So based on this diagram here, we can see an expectation of what we expect the values of cosine and sine to be based on the angle within the unit circle. So we've got a mnemonic to remember this, and we can say all stations to central. And what this tells us is that in quadrant 1, so Q1, we expect all of our trig functions to be positive. For Q2, we expect only sine to be positive. For Q3, we only expect tangent to be positive, because remember, tan is the same as writing sine over cosine. And for quadrant 4, we expect sine to be negative but cosine to be positive, or only cosine is positive, so tangent's going to be negative as well. So looking at this, why are some angles negative? Well, they're negative because of the location they're at on this Cartesian plane. Now, looking at negative angles, when we have, let's see if we can scroll down. Here we go. Another unit circle. Alright, so when we're working with our angles, so say if we're starting from here, and say we're going to 3 pi over 2, then what we do is we're starting at this 0 radians, pi on 2, pi and 3 pi over 2. So we're starting here and we're sweeping around and we're going all the way to this location here. So this would be 3 pi on 2. But what about if we had, negative 3 pi on 2? How would that work? Well, remember the positive direction of the unit circle is going anti-clockwise, and the negative would be therefore clockwise. So we would go, starting from the 0 radians, we'd go backwards along the unit circle, and we'd spin around by 3 pi on 2 radians, which would take us to this location here. So in which case the cosine of negative 3 pi on 2, because we've spun backwards, we're at this location here, and simply looking at that, I know that's location 0, 1. So the cosine of this is going to be the first number here, 0, and the sine is going to be 3 pi on 2. The sine is going to be positive 1. Conversely, for the sine of 3 pi on 2, which would be represented by this black line here, this would be 0 and negative 1. So the output of this guy would be negative 1. So notice the difference in the negative values. They swing clockwise. They swing clockwise around the unit circle, where the positive values go anti-clockwise. So it's all about looking at where that angle would finish up, or that point would finish up after sweeping this distance clockwise around the circle. And what was the final question? So what about if the angles aren't listed on the unit circle, such as 5 pi on 2? Well, again, remember the concept of being periodic. So let's just copy this and we'll put it down here. Alright. So let's say 5 pi on 2. We'll think about it. If we go around the unit circle, we're going to go, the full circle is 2 pi radians. And what happens if we go and we start Well, what happens if we get a value above 2 pi? Well, let's break this down in terms of 2 pi, and we'll say this is 4 pi over 2 plus pi over 2, and that can be written as 2 pi plus pi over 2. So what would happen in this situation here? We'll consider if we start at 0 radians, when we swing around by 2 pi, we get to this location here, and then we go an additional pi on 2. So what we're expecting is we can get rid of that component there because it's just one trip around the circle. What we're wondering is where we finish up. So we simply look at the fraction or the part of 2 pi radians, and that's pi on 2. So for this, cosine on pi over 2 is simply going to be 0 because we're at this part here, and then sine on pi over 2 is going to be a value of 1. So hopefully that explains all of the questions listed here.